Dr. Atchison here. We're still talking about Chapter 7, Perception for Motion and Perceived Action. Now we're on to that perceived action part of Chapter 7 in our 4th video lecture. So perception for action, we used to think that they were separate, that perception and action were two separate things and we could look at them kind of discretely. The more research that's been done in the area, the more that we realize that it's kind of an ongoing feedback loop. In fact, that perception is a form of action. And that we can't really separate these in any way because, again, it really is this loop. We perceive something, we act, we perceive that action. It's that ongoing bidirectional back and forth relationship between perception and action. And work by Gibson really suggested that much of the information that we have about different locations and surfaces, about our environment, is specified by the changing geometry of on our retina. So how that retinal image moves and changes, according to Gibson, he was the first one to really say that that's what we were getting about information about locations and surfaces, that it was coming through this kind of movement, and that then that was enabling action. So back to those various pathways that we discussed earlier in the text. The ventral pathway, that what pathway, information about movement that will guide our actions, such as reaching and grasping, really travels through the ventral pathway to area V4, and then into regions of the lateral occipital cortex and the inferotemporal cortex that are really, again, involved in that object recognition that we talked about in Chapter 4. Because to be able to act on something, you have to have that piece of object recognition. You have to understand that what. But of course, what's going to be very important is going to be the where-how pathway, that dorsal pathway. That's how the information is getting into MT, which we talked about in the first lecture, was so important for recognizing movement. So both of these pathways are really having to work together for our perception of motion and our perception of action, to be able to act on these things. We have to understand kind of where things are, how to get them, what they are, to be able to act on them. And the parietal lobe is really well suited for this based on where it's positioned in the brain. So we think a lot of guided action is really happening there because it's so close to motor regions of the prefrontal cortex. So again, to be able to act on something, that perception action link is again going back and forth. We have to have perception to be able to act. These things are really intertwined. And so we have information going on both the ventral and the dorsal pathways to be able to work this out. Several areas of the dorsal pathway, again, have been identified as important for reaching and grasping. And primarily these have been done with monkeys, but we have some human studies that back this up as well. And again, the parietal lobe, specifically the posterior portion of it, seems to be what's most important. Your book talks about these different areas, the LIP, the MIP, and the AIP. We're not going to go into a lot of detail about those, but we see information from, again, monkey models that the eye control movements are happening here in the parietal lobe, that the reaching and planning, these reaching movements is happening in the parietal lobe, and so is the grasping movements, that all three of those things are really happening right there together. So that we think that really this posterior part of the parietal lobe is where a lot of this action piece of it's going on. So not only do we have the information about motion going in that dorsal pathway, but we also have that information about action going on. And that ventral pathway is going to have the information that's related to the objects that we're acting on. Optic flow that we talked about in terms of our depth perception chapter 6, is also important here. So remember, optic flow is kind of the things that move around you. We showed you that video of the baby in the moving room that to illustrate optic flow. That's what we're talking about here. And so again, that's that information that's carried by light streams as a result of the structure of your path through the environment. So as you walk through the environment, things move past you while you're heading towards something. Things move past you, this optic flow, and that's that information. And this allows us to avoid obstacles, to get to goals in novel ways, if I have to navigate my daughter's playroom, I can do this in this cluttered environment because of optic flow, so that I can act in a safe way through the mess of toys in her room. We also can do this, and part of this is focus of expansion. And this is that optic flow field is produced by the movement that we move forward in space. And it includes that center point on the horizon in terms of the perspective image. So when we're moving towards, if I'm moving towards something, that's that point that I'm trying to get to. And it tells me where I'm heading. The focus of expansion is kind of how those things change as we move toward our navigation goal. So it's this idea that the retinal image is kind of changing or flowing more outward from the center. This is that idea of that focus of expansion, that as we move towards a goal, and this gives us information so that we can reach our goal in really appropriate ways. We can see this research with optic flow is documented in houseflies, and they will adjust their flight patterns based on the visual input from optic flow. So they can modify what the optic flow kind of perception is. So kind of like the moving room, only for flies. And they will change their flight pattern based on that information. So again, this optic flow information, this perception of our own movement is important in the action that we are engaging in that movement. And so again, while that video that we showed it was about for depth perception, really action was an important part of that. We saw the difference between the infant that hadn't crawled yet, not noticing that optic flow, whereas the child that had crawled did notice that optic flow. So again, that this action is so linked to this perception that we don't actually develop some of these perceptive things until we have this action, that they really are that important to each other. They'll also tether the flies so they can't fly away, and they'll place them in a chamber and are able to kind of change the presented visual images to them. And again, the flies will adjust their flight to match this fake information that they're giving them from like these moving rooms. Your text actually talks about this moving room in terms of adults. These people get to stand. They don't have to sit in a high chair. And again, this affects our posture. We remember those babies readjusting themselves. We would do the same thing. This information that we're getting from the bottoms of our feet and the way we tilt one way or another based on optic flow, based on this information around us. So the neurons and the muscles and the joints provide information. And again, this back and forth between our perception of movement and our action. So here again, they're modifying the perception of movement. And so then we will change in action in movement. Again, these things are very, very linked. And again, that baby human video is a great example of how linked these two things are. That concludes our discussion of Chapter 7, Perception for Action, Perception of Motion and Perceived Action. Thanks.